For many years, Mars has been regarded as a dry wasteland that has managed to capture the attention of scientists because of its similarities to Earth, with the major difference being the whole no life part. Aside from that major difference, the similarities between the two planets seem to be piling up as scientists have recently discovered what could be ice glaciers on an unexplored part of the planet. There is a possibility that these glaciers are made up of frozen water, and if that's the case, this discovery will change the outlook of Mars missions in the future. Today on Super Freaky Science, we'll be looking at the implications of glaciers on Mars that could produce water and how they might support human life. History of ice on the surface of Mars. For quite some time, Mars has been regarded as a dry planet, with the abundance of iron oxide on the surface giving it its red outlook. With its deserts being twice as hot as the hottest place on Earth, Mars was pretty much considered a barren wasteland, and with good reason. In recent times, a handful of unmanned space missions focused on finding evidence of biological life on the surface of the planet has taken place. These missions were carried out in hopes of strengthening claims that the planet could sustain life, or did at some point in its 4 billion year existence. The planet's two polar ice caps are visible from space, covering relatively large chunks of the North and South Poles. But unlike Earth, where the polar ice caps are made up of frozen water, the ice caps of Mars don't melt into water during the summer seasons. They are instead made up of frozen carbon dioxide, dust particles, and water vapor. During the long winter seasons, the planet's surface temperatures reach sub-zero levels and freeze the CO2 and dust particles, forming what is called dry ice. This dry ice is what we see covering the polar ice caps, and instead of melting during summer seasons, this dry ice sublimes, releasing gas and CO2 back into the atmosphere. New images of the planet have shown a series of ripples and flows on the dry, arid surface. Together, these images strengthen the theory of the existence of water on the planet. The ripples seen in the images are cautiously referred to as viscous flow features because of their striking resemblance to rivers and gullies that flow here on Earth. The Mars Renaissance Orbiter picked up a radar image of large masses of ice glaciers buried underneath the planet's rocky surface. Analysis of the images carried out in 2008 confirmed that the rocky debris on the surface might have protected the icy glacier underneath as remnants from the Ice Age millions of years ago. This is strikingly similar to underground ice packets and glacier masses found in Antarctica from the last ice age. And unlike the ice found on the planet's polar ice caps, these glaciers may very well be made up of frozen water. With the race to ferry humans to Mars well underway, scientists believe that these underground glaciers may be a sufficient source of planetary water. Discovery of underground ice glaciers. The underground glacier discovered back in 2008 were hundreds of meters deep underground, but recent studies have found glaciers much closer to the surface. The planet's mid-latitude desert shows promise of submerged ice close to the surface, none more than those found in a region known as Arcadia Peninsula. Arcadia is a smooth, flat plain located in the northern lowlands of the planet. Viscous flow features fill the surface of Arcadia and have led scientists to believe that water might have flowed out of these underground glaciers at some point in the planet's history. A new scientific study led by Sharon Hibbard, a PhD candidate in geology and planetary science, currently ongoing at the University of Ontario, Canada, sheds more light on the discovery. Hibbard and her associates co-authored the scientific paper Glacier and Glacier-like Activity in Arcadia Peninsula. This paper revealed some promising information about the prospects of the underground ice packs. Mapping of the surface of Arcadia via telescope has shown the presence of viscous flow features in large numbers scattered all over the surface and stretching for miles and miles. This is quite unusual for a flat plain like Arcadia. It is more common to find this kind of surface ripples on highlands and ridges where the action of gravity pulls the surface ice down below, causing these distinct flow features. The unique features of the Arcadia Peninsula aren't just the glaciers buried underneath, but the relatively smooth nature of the surface as well. This flat, smooth bed is perfect for landing a space rocket, maybe even Elon Musk's Starship itself, which is fast becoming the planet's best and closest bet for landing the first humans on Mars. Landing on a smooth surface with proximity of glaciers with potential for water resources makes the Arcadia Peninsula plains of utmost importance to the future space missions to Mars. Could the glaciers produce water to support human life? Presence of these glacier activities on the surface of Mars is by far the most exciting discovery we've made on the planet. Because of their composition and potential to be made up of water, the glaciers hold great promise for future human landings and exploration. Until we can land a rover or maybe even astronauts on Mars, studying the glacier from Earth will be our only option, and it's quite the task. Telescopes and imaging from the Mars Renaissance Orbiter are our only bets for studying the possibilities of the underground glaciers. But the good news is, Hibbard and her team think the glaciers aren't unique to Mars alone. The team of scientists has identified striking similarities between the Mars glaciers and buried glaciers here on Earth. The underground glaciers and the ice streams in Antarctica have been found to move at considerable speeds faster than their surface surroundings. Hibbard's team have deducted that this is made possible by a difference in the underground topography. The surface of Antarctica is below sub-zero temperatures, but beneath the surface, which is closer to the Earth's core. This is considerably hotter and is responsible for melting the glaciers beneath, causing them to flow and move through the Earth's crust. While the flow features beneath Mars' surface do not flow at all, they seem to have accumulated over time and might be much deeper and larger than initially thought. Finding possible flow features in this flat-lying region is very exciting. Previous studies have suggested that these buried ice sheets at our study site and our evidence of channelized ice within the ice sheets indicates that there is more complex glacial dynamics at hand on Mars. Hibbard disclosed in an interview when asked about the implications of these glacial systems on the Red Planet. In recent times, a debate about the feasibility of extracting the underground ice and making it useful for human astronauts when they eventually arrive on Mars has ensued between scientists. On one hand, many scientists have disputed the fact that these packs of ice would be useful to humans. Astrobiologist Nilton Reno from the University of Michigan expressed the difficulty or relative impossibility of extracting whatever water there is in Arcadia Peninsula. Many glaciers are in regions more challenging for human exploration because of the lower temperatures during the winter and topography, even though in high latitudes the water ice is easily accessible. A report by John Walt of the University of Austin, Texas stated, "Altogether, these glaciers almost certainly represent the largest reservoir of water ice on Mars. That is not in the polar ice caps. Just one of the features we examined is 3 times larger than the city of Los Angeles and up to 1/2 mile thick. And there are many more. In addition to the scientific value, they could be a source of water to support future exploration of Mars." This gives hope for future crewed missions to the planet, but of course more analysis needs to be done to be sure of the viability of these findings. What if these glaciers are packed full of actual water? Do you think it might be possible they hold some sort of aquatic life frozen in time? Let us know what you think down in the comment section, and be sure to give this video a thumbs up. Don't forget to hit that like and subscribe buttons and check out some of our other videos as well.